All right, so today we are going to talk about translations. Our objective is to be able to describe a translation using algebraic notation. Our central question that we're answering is just what are the effects on the x and y coordinates of various translations? So when you're moving a shape around the coordinate plane, what happens to the x and y coordinates? And we'll write notations for that. Um, First, start definition. A translation, maybe referred to as a slide, refers or it moves each vertex of a figure in the same distance and direction. Right, the figures will be congruent after the translation. Right, you can maybe remember that a translation is a slide. There's an SL in translation, and then slide also starts with SL. So that may be helpful. And so, just a quick visual of what a translation is. It says that every vertex of a figure is moved in the same direction, right? So a vertex is like the points um, on a shape, right? It's where a vertex is where two lines meet. So if every vertex is moved in the same distance and same direction, that's how the whole shape moves. So if we call this vertex A and move it 5 units to the right and 3 down, um, it would look something like this, right? I'll take vertex A and move it 1, 2, 3, 4, 5, and then 3 down, 1, 2, 3. And now this shape has been translated. This would be called A prime, and it's been translated 5 units to the right and 3 units down. And every point would also have had that same movement. So if we call this B, and if we count it over, 1, 2, 3, 4, 5, and then down 1, 2, 3, right? That's B prime. Like every point is moved in the same distance, the same direction. So that would be true for C and D, which would make these C prime and D prime. And also it said the shapes are congruent, right? So these shapes are the exact same size. Let's talk about the kind of language I used on the last screen. The image and the pre-image. The pre-image is the original shape, right? So in this one, the pre-image would be this shape here. The original shape has the letters that have nothing next to them, not like over here, right? It'll just be A, B, C, D, or whatever the letter is, but it'll just be the letter by itself. And then the image is something that happens after the transformation, right? After the shape has been moved, that's called the image. And you will notice the image because of this little thing right here. It's called a prime mark, right? So this indicates that this is the second of the two shapes. And that will be a key way that you can identify them. All right, so here we have some steps on how you would translate something, and then how you could write the notation for it. In this case, the translation is already done, and we want to be able to describe what happened in the translation and then write an algebraic notation for that. So I'll talk about each piece of it, like of the just describing the translation, and then refer to this example over here, and then come back to writing the notation, and then write a notation for it. And so describing the translation, first we want to pick a point on the pre-image, right? We know that this is the pre-image here because all the letters are just the letters by themselves, so that makes it the pre-image, right? So pick a point on the pre-image and then find the corresponding point on the image. So I'm going to go with point A, and so then that means the corresponding point would be A prime on the second shape, right? Now I'm going to count how far horizontally the shape went. Right, horizontally is left and right, so either I'm going to go left or going to go right. In this case, we're going to go right because I'm going to go as far horizontal as it takes to get lined up with A prime. So I'm going to go ahead and count that. It's 1, 2, 3, 4, 5, 6, 7, 8. Right, and so I'm write that down. I went to the right, 8. And then I'm going to count the vertical movement. So vertical is up and down, or up or down. And count how far. In this case, I have to go down. So from 8, I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. So I went down 8. right? So that would be just describing the translation. That tells me how the shape moved. It went to the right 8 and went to the down 8. And again, that would be true for any of the points that you picked. If you started with B to go to B prime, you would go to the right 8 and down 8, and the same with C. Now we're going to write an algebraic notation to represent the translation that just happened, right? So when we going to write our algebraic notation, we're going to refer to the description that we already wrote, right? This is going to help us write that algebraic notation. Very simple. So every algebraic notation begins with x comma y, right? And this is kind of like telling the story of the translation. First, we start off with a point that's x and y, right? So that might represent any of these points. And wherever it was from the original point, now we're going to tell how it transformed. So I'm going to start a new parentheses. And so next is to use the horizontal movement to write the notation for the coordinate plane. So example of that might be if I move to the right 5, I would say x plus 5. Or if I move to the left 2, I would say x minus 2, right? So movements to the right are positive, and movements to the left are negative. So I would subtract. In this case, I went to the right 8. So I would do x plus 8. And then go to the vertical movement. Any vertical movement going up is going to be positive. So I would do plus. Move this up a little bit. So I would add if the movement was up, and if the movement is down, I would subtract. This movement is down, and actually I went down 8. So I would do y minus 8, right? The x movement tells you horizontally, left or right, and the y movement tells you vertically up or down. And so this would be the algebraic notation to represent this image. All right, so here we have some examples. Describe the translation. So again, I'm going to pick a point and then to see how it moves. So in this case, I'm going to go from C to C prime, right? C is the original, and C prime is the image after. So I'm going to go from C to C prime and see how far I went. So I'm going to the left in this case. So left 1, 2. So I'm at left 2. And then down 1, 2, 3, 4, 5, 6, 7. So I went down 7. Right? And so I could write my notation now just from that. Left 2, so xy is my notation, and then starts off, I do my x, so it's left 2, so x minus 2, and then I went down 7, so going down is also going to be subtraction, so y minus 7. I'm going to go ahead and plot these points. I think it's good practice that we can plot points, and then I can also show you with the points exactly what's happening here. How this notation represents what's happening to the points. So I'm going to go ahead and get all these points down. A is at negative 2, 1, 2, 10. B is at negative 1, 2, 3, 4, 1, 2, 3, 4, 5. So B is at negative 4, 5, and C is at 0, 1, 2, 3, 4, 5. Right, and then the prime points, right? These are the after the transformation. You go with A is at negative 1, 2, 3, 4, 1, 2, 3. So negative 4, 3. B prime is at negative 1, 2, 3, 4, 5, 6. Negative 1, 2. So negative 6, negative 2. And then C prime is at negative 2, negative 2. All right, and so if you look here on the x coordinates, every x coordinate, here are the x coordinates, 2 was taken away from it, right? X minus 2, so this is the original x, minus 2 is negative 4. Negative 4 minus 2 is negative 6. 0 minus 2 is negative 2, right? So for every x coordinate, you're subtracting 2. And on the y coordinates, right, it's y minus 7. So for every y coordinate, you're taking away 7, right? 10 minus 7 is 3. 5 minus 7 is -2. 5 minus 7 is -2, right? So here are the points, and you can see what's happening to them with the notation. So here, I'm going to go through these. Here first, start with the prime point. I'll pick D prime, or D, the original, to go to D prime. So I go to the left, 1, 2, 3, 4, and then up, 1, 2, 3, 4. So left 4, up 4. And with that, I can go ahead and just write the notation, right? Left 4 is x minus 4, and then going up 4, now I'm going to add, so y plus 4, right? I can go ahead and do my coordinate points also. So A is at -2, 4. B is at 0, 4. C is at 1, 1. And D is at -3, 1. And then I can go ahead and do the prime marks as well. I'm going to go ahead and just use the notation to get these points, right? So A prime is -2, so -2 minus 4 is -6. And then the y is adding 4, so 4 plus 4 is 8. So that will make this -4, 8. That will make this C prime -3, 5. And D prime would be -7, 5. Right? So really, I'm just following the notation rules to come up with the new points. And then I can verify those just to make sure. Is point A prime at -6, 8? Well, let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Right? So I'm just using the addition and subtraction from the notation, and then I can know where the other points are. And here's a you try. So I want you guys to try to describe the notation, write the or describe the translation just in words, then write the notation for it, and then you can plot your points or verify where the points are.